Hey, hello. Welcome to lesson 32, which is quantum mechanics. Now, it's worth mentioning that we're actually on the cusp of kind of a new kind of physics. We're moving actually from classical physics to quantum mechanics, which is going from the physics of stuff that you can see to the physics of stuff you really can't see. Now, this has some interesting effects. One being that you can't actually prove a lot of your theories because you can't actually test them. But it also means it's very difficult for people to trust or believe in your theories because you can't actually test them. Now, up until now, physicists had spent a lot of time trying to explain how EMR was like waves with the work of Huygens and Young's double slit experiment. What we're going to find now is that the idea of waves as a method of explaining EMR is going to fail. That it can't explain everything, and in fact, we have to go back to the idea of some form of particles to explain EMRs in its entirety. Now, the first real experiment that caused grief with EMR being a wave is blackbody radiation. This is the idea that if you blast stuff with EMR, with electromagnetic radiation, that whatever it hits, kind of stuff kind of bounces back off. So that's Newton's third law. For every action, there's an equal and opposite reaction. Throw stuff at something, some of it's going to heat up the object, but it's going to give stuff off. And the general idea is if you keep adding stuff, if you keep cranking it up, you're going to get more coming off. In a nutshell, this isn't true. What happens is at some point it starts to fall off. You blast it with stuff and less stuff comes off, which really doesn't make sense. You can kind of think of it like turning on water, like a water tap. The more water you turn on, the more stuff gets wet. And so, obviously, the more you crank up the water, the more and more stuff gets wet. But for some odd reason, at a certain point, you keep cranking it up, things get less wet. It seems to be not coming out as fast. It just doesn't make sense with classical physics. Now, if we look at the graph, we can see that as you increase the frequency down here of EMR, the intensity of the EMR that is given off, that radiates off, goes up. And this holds true for a certain amount of time. So when you're down here, EMR of a lower frequency, this would be like a red light, orange, green, and so on, up to indigo violet. And higher, the intensity starts to drop off. And the question is why? Why does it not continue in the manner predicted by classical physics? And the reason is that EMR isn't just like a wave, it's actually also like a particle. If we go back to the water tap analogy, the reason why classical physicists get confused when people don't get as wet when you crank up the tap at a certain point is because what's really going on is that there's more energy in those drops of water that are hitting things. That somehow, even though the drops are really small, they're containing more energy. Now, this doesn't jive very well with standard wave theory because waves are continuous and the energy kind of just flows. So there has to be some kind of compromise at this point. Now, of course, what had to happen was someone needed to come along with a theory that could be explained mathematically that would make sense. This was Max Planck, or Planck. And the essence of his theory was that energy traveled in small packets or pieces known as quantas or quantums. Once he divided energy up into pieces, he could mathematically come up with a formula to calculate how those pieces would move. And with his simple formula here, E is equal to hf, he basically said that the packet of energy that a wave would give off is directly related to its frequency and his constant, Planck's constant. So a higher frequency wave has packets of energy that are larger. So UV light, for example, which is a higher frequency wave, is going to have a packet that's got more energy in it. A red light is going to have a packet too, but it just contains less energy. So while you perceive intensity as the number of packets given off, there's really a hidden energy in the packets themselves. UV is just simply giving off less packets, but the packets have more energy. Now, this reversal of going back to particles as being a key fundamental component of EMR represents the foundation of quantum mechanics. This famous dude here, Albert Einstein, actually runs with this idea as well, applying it to light particles, giving these packets of energy a name known as photons. And while in the beginning here this idea of quantum mechanics doesn't have a lot of mathematical background to support the theory, we're going to see in the next couple of lessons that the evidence is going to be compounding and compounding until the point where quantum mechanics is an accepted theory and a divergence from classical physics. Well, that's it for today. Hope you liked and enjoyed your introduction to quantum mechanics and the quantum theory, and we'll see you during the next lesson. That's it for now.